All right, guys, let's go ahead and get started. So with this proof, we're given PW is congruent to TM, PM is congruent to TW, and we want to prove angle P is congruent to angle T. So go ahead and pause the video, try this one out on your own if you'd like, and then we'll be working through it together. All right, so to get started on this, we're going to go ahead and start out with our given information. So I'm just going to go ahead and put PW is congruent to TM and PM is congruent to TW. I'm going to put those as my first two statements. And of course, my reasons are that they're given to us. They're in the given information. Now, from here I can see that PM, this is the whole entire segment here, and WT is also the whole entire segment here. So I'm showing that they're congruent just by writing that it's congruent on the outside. That way I'm not getting confused on, am I talking about PS and ST? Am I talking about WS and SM? What am I talking about here? If I draw these congruency symbols, that's telling me, hey, this entire segment is congruent to this entire segment. Now, from here, looking at these two triangles, I'm trying to prove that WPM, this triangle here, is congruent to triangle MTW. So that's our goal. So, is there anything that's shared by both those triangles? Well, yes, WM. So I can say WM is congruent to itself. And any time something is congruent to itself, it's always by the reflexive property. So WM is congruent to WM by the reflexive property. Now from here, we should have enough information to prove that those two triangles are congruent. So we can say triangle PMW is congruent to triangle TWM. So again, you can write it in any way that you'd like. Just make sure that your corresponding points, your corresponding vertices are matching with one another. Now the way that we can say that is because we have a side, and a side. So this is congruent by side, side, side. Now, at this point, now that we know that the two triangles are congruent, we can say that all the corresponding parts are congruent. So I can say angle P is congruent to angle T, so these two angles are congruent, and that is by CPCTC. And with that, this proof is finished. All right, so the main topic of today's lesson is overlapping triangles. Our learning target is I can write two-column proofs involving overlapping triangles, isosceles triangles, and circles. Now, we've already covered circles in one of our previous videos. We'll be covering isosceles triangles in the next video. So today we're going to focus extensively on overlapping triangles. And we're not going to do too much for this. We're going to go through a couple proofs with this, and then the rest of the time will be pretty much just practice on it, because it's very similar to what we've been doing already. In fact, we already saw it on our prior screen. These were overlapping triangles because they're overlapping each other and they both shared a common side length. So this is an example of overlapping triangles. And we can see that occurring right down here. So again, we're going to be focusing solely on those. Now, some tips to get started with overlapping triangles. The first thing that we need to know is we want to outline the different triangles in the proof. Oftentimes we're going to see multiple triangles in these types of proofs. It's very important that we use our given information to see which triangles I can actually prove are congruent. Now, sometimes you're going to notice that you're proving the wrong triangles are congruent and you get stuck. If that happens, go ahead and just take a second, look through your given information, and then see what you're trying to prove. And again, what we're trying to prove in the givens all should be on the same triangle. If they're not, then you're probably not going to be able to prove that they're congruent right away. Or it will be a detour type proof where we need to prove something, two triangles are congruent before we can actually do what we're trying to do. So it entirely depends on what we're given, but if you outline those triangles and focus extensively on the ones that you're trying to solve, then you'll be able to prove those a lot easier. The other thing that we need to make sure of is we're using the correct postulates. Again, we have three postulates so far: angle, side, 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 and side, angle, side. So these are the three that we're going to be using for overlapping triangles right now. Now, you'll be learning about HL next week, but for right now, we only need to worry about these three. So make sure that you're making your congruency marks on your picture, and that way you can see where you have angle congruency marks, side congruency marks, and another angle congruency mark. Because if you see those, then it's a lot easier to know which postulate you're using. Now, again, we've been talking about this since we started doing proofs. Make sure that you guys draw what is given to you on the diagram. Then think about what else you would need to prove the triangles are congruent. But use what you have to get started. Use all that information to get started. And then once you do that, you can start using the diagram itself and what you see is overlapping and things like that. Now, again, since they're overlapping triangles, they'll often share a piece of the triangle, whether it be a side or an angle. And if they are doing that, then you're going to be using the reflexive property. So look for those overlapping portions, whether it be a segment or an angle, and when you see that, you'll automatically know, hey, that's reflexive property, and you'll be able to have a piece of your triangle right away. All right, so let's go ahead and try one out. Here's our first one for today. We're given AC is congruent to AB, and AE is congruent to AD. We want to prove segment CE is congruent to segment DB. Now, I already outlined the triangle that I'm working with, but as you can see, there's a lot of different triangles here. I have this tiny triangle here, and this other tiny triangle. I also have triangle DCB down here, and triangle ECB. So again, determining which triangles you want to use is based upon the given information. So I write out my given first, and I can see that AC is congruent to AB, and AD is congruent to AE. So if I look at this, I have this red segment and this blue segment. So those two segments are two sides of my triangle. So that automatically tells me, hey, I may want to use these two sides to prove triangles are congruent. Further, I look and see that I'm trying to prove that CE is congruent to BD. So those are these two segments on the bottom. Now, if I want these two segments to be congruent as well, well, that would create this triangle, triangle CEA. So that tells me that this is the triangle I want to prove, which is why this is now blended in. This is why this is colored in right here, so that we can see which triangles we're trying to prove. Now, if that's the case, we already have two sides. Again, we have side AC and side AE. So now we either need another side, which probably isn't going to happen because that's what we're trying to prove, or we need an angle. We need a certain angle. So, looking at this diagram now, is there anything that's shared between the two triangles on the diagram? Well, yes. They both have angle A. So I can say that angle A is congruent to itself, and that would be, of course, by the reflexive property. Well, now looking at these triangles, they look congruent. So I can say triangle AEC is congruent to triangle ADB, and we just read the congruency mark. So I start anywhere on any triangle, and I'll just start down here. And I just start looking for a congruency mark. I don't see anything. I'm just moving around. Oh, side, angle, side. So these two triangles are congruent by side, angle, side. Now, if the two triangles are congruent, well, doesn't that mean that all the corresponding pieces would be congruent? Well, yes. So we can say CE is congruent to BD, which is what we're trying to prove. And the reason I can say that these two segments are congruent is because if the triangles are congruent, then the corresponding parts of congruent triangles are also congruent. So that'd be CPCTC. Corresponding parts of congruent triangles are congruent. And with that, this proof is finished. All right, so that's our first proof for overlapping triangles. Let's see another one. All right, so for this next one, we're given FH is congruent to MJ, G is the midpoint of FH, K is the midpoint of MJ, and we also have angle GHJ is congruent to angle KJH. What we want to do is we want to prove segment GJ is congruent to segment HK. So, to get started on this, we're going to go ahead and write out all of our given information. And go ahead and pause the video if you need to, and try and figure this one out on your own first, and then you can unpause whenever you're ready. So I have all my given information here, and I mark it up on my picture. So I have FH is congruent to MJ, I have G as the midpoint of FH, and K is the midpoint of MJ. And I also have that angle GHJ is congruent to angle KJH. So all that information is given to us. Now, I chose this triangle down below here, triangle GHJ, because first off, I'm given FH and an angle down here. Now, if I try and prove this triangle, well, there is no triangle with FH total, but I can use GHJ. Further, our goal is to prove that GJ is congruent to HK, which are these segments right here. So we need to prove that these segments are congruent. Well, that's part of the triangle. So to get started on this, we can go ahead and say that GH is congruent to KJ. And you may be wondering why I did that. Well, if you recall, we see the words midpoint written twice. And any time that you see midpoint, bisect, trisect, anything like that written twice, that automatically opens up division and multiplication properties. Now, if we look at this, we're going from a large segment to a small segment. So if I'm going from big to small, it's going to be the division property. And that's where the division property came from. So I now have GH and KJ being congruent to each other. Well, from here, is there anything that's shared by both triangles? Well, yes, they both have HJ. So I can say that HJ is congruent to itself by the reflexive property. So these two segments, HJ and HJ, they're congruent to itself. And again, we can see that's on both triangles here, not just one of them, but on both of them. So now we should have enough information to say that they're congruent. So I can say triangle GHJ is congruent to triangle KJH by side, angle, side. Now, if the two triangles are congruent, it would make sense that the corresponding parts are as well. So you should be able to say that GJ is congruent to HK. And of course, that's because if the triangles are congruent, then the corresponding parts of the congruent triangles are also congruent. So CPCTC. And with that, that proof is finished. All right. So with that, we are now finished with today's lesson. Again, it was just overlapping triangles. It's pretty straightforward. You're just doing the same proofs. Just the overlapping parts are congruent to each other by the reflexive property. That's the main thing that we wanted to make sure that we got through today. So you guys do have homework. It is available online. And if you guys have any questions, just let me know. I'm happy to help you guys out. Thank you guys so much for watching, and I'll talk to you soon. Take care.